It is an early release, so it's not exact final hardware, but you get the idea looking at it of exactly what's included. And so I'll also show a simulated version of that a little bit later on, but if we have a look at the actual hardware, the basic concept is that you put a laptop on here. Now, RDS, of course, runs on Windows, uses .NET, etc. But we've designed this in such a way that it's very, very easy. You just put your laptop on there, you plug in a couple of USB cables, and you're good to go. So there's not a lot of messing around. The platform itself is, in fact, targeted primarily at education, research type market. And for that, we've deliberately put in a couple of heavy-duty batteries underneath. They're down low, keeps the center of gravity low, so it's hard to tip it over. And we expect that those batteries are going to allow the robot to run 5 or 6 hours.
Yeah.
So if you consider a situation where you've got a bunch of students sharing a robot, which is quite common, I mean, you're not going to go out and buy one per student, then the long battery life of the robot is good. It'll probably last longer than the battery life on your laptop. So the students bring in their own individual laptops, plug them in, switch them over, and you could put half a dozen students through there in a space of a day and then recharge the robot overnight. So that was one of the design criteria that we had when we put this together.
And I can see here that we have a Kinect on the top of this. Is this the device from Parallax?
Yes, it is. This is our simulated version, and it looks very similar because, of course, it's taken off the CAD drawings.
Yeah.
So it should be pretty similar. Basically, if you wanted to do something like design your own obstacle avoidance algorithm, or if you wanted to do some simultaneous localization and mapping, which is a very common theme in the research field, you can do that in this environment. So what we've got here, as I said, is the simulated robot itself with a simulated laptop on the top, which does nothing. It's cosmetic.
Yeah.
And then there's a Kinect on the top. Now, the Kinect itself, I can actually tilt the Kinect up and down. Okay, you can maybe see that moving there. We have the depth data and the RGB data from the Kinect that are visible. I can use my trusty Xbox controller here, of course, and I can drive the robot, and the data updates. So the depth data is in grayscale. That's the window on the top there. And you'll notice it fades out to white.
Yeah.
Now that's basically, there's a limitation on the range
That's
of
as far
the
as it
camera.
can see.
That's as far as it can see, exactly, yes. And you can drive it around, play games with it, but basically the key point is to program it.
Yeah.
To do that on its own. So, you know, we put the Xbox controller aside, we fire up an obstacle avoidance algorithm or some sort of mapping algorithm, and it drives the robot around. Now, the nice thing about this is twofold. One, this software is free. You pay nothing to get to this point to program the robot. You don't have to go and buy a reference platform on day one. So you can try it out, get a feel for it, and
so
then when you're
started
happy,
with robotics, it's a zero-cost game to start out with.
Exactly, and that's important for education, of course.
Yeah.
So you can do that. The second thing is, if you do crash into something, you don't break your Kinect, right?